Guys, thank you. Just come back to me for a while. I like the fact that you're collaborating. That's really good. And you need this for the remainder of the course, but not for the next 45 minutes or what's left of that anyway. So let's do a bit more Linux, and then you're surviving it, and you move on to other more interesting things. But it's just part of your profession to know some of those commands. So so instead of going through all those individually, the ideas there, then we just talked about modifying objects, files in this particular case, and the commands that are available. What I want you guys to do is not so much to be fully proficient in all those commands, but rather have a vocabulary in mind, or a starting point at least. Okay, I want to see that and look into that file. What do I do, right? I want to create a file. I want to move a file. How can I do all that? And that's basically what this one here is about. So we're looking to creating files, viewing files, and you can look at all those in greater detail yourself as well. I'm not sure, did you talk about the help, standard help for commands?
We discussed that.
Great, okay. Yeah. So worst case, look up the -- help to figure out how the commands actually work and so on. Usually they have a reasonably clear description of the syntax. So one other command is for, that is oftentimes confusing, is for moving and renaming. So when you want to move a file or rename a file, use the same command in Linux. And that's the, well, MV, the move command. Why is that confusing? Or is that confusing? Good. You're not Windows polluted, because most Windows users would say, well, hang on, don't you need two commands for that one? Because in Windows Word you have two. So, but moving and renaming is the same thing. So you leave the file the same place, give it a different name, use move. Moving a file from a place A to place B, you also use move. Good. So changing files, of course you can use your editor, but there's sometimes easier ways of just appending, for example, a line of code, if that's what you need to do. For example, this double greater than idea here. So I'm going back to my home directory just to highlight it briefly, and I had a test file in there, I think, and if I use my greater than again, and I do cat on my test file, so I echoed test2 into test here, and if I now call cat, you'll see there's only test2 contained in there. The issue is there that a single greater than will basically overwrite the content, whereas if you have a double greater than symbol, it will append. So you can append files. So if you want to have a cheap way of writing log files and logging things, you can just append by having this double redirection symbol.
One addition is that it will always append it to a new line.
Yeah, that's right.
So it will always insert a
line. \n, right, as a symbol. That's right. Yes, that's good. That's right. But it makes it so useful for having log files, right? Okay, and the last command would be deleting. rm remove, right? So if you want to delete files, use rm. So of course, we not only having files, we also have directories, and the commands kind of are overlapping yet slightly different. If you want to create a directory, that's probably one of the few commands that's longer in Linux than it is in Windows, because mkdir make directory. What is the command in Windows? In batch, how in the command line, how do you make directories?
mkdir?
Sorry?
Isn't it the same?
md, I think. md, make directory. So that's the only one that's simpler. But I haven't found any other one that's simpler. So ls, as I showed you before, is for listing. List anything in the current directory, right? Really straightforward. It's worthwhile memorizing. mv for moving again. cp for copying. So you want to copy directory. That's roughly the same as in Windows, only that the command is called copy in Windows. And deleting here is slightly different. We have rm for remove -r. And this -r, does anyone know what it stands for? Let's take someone else. Him, because he hadn't talked yet.
Recursive.
Recursive, right? So what does it do?
Essentially goes and removes everything in that folder from all the subdirectories.
Exactly, right? So the idea is there, you say rm-r directory, and it really goes systematically through all the subdirectories, deletes everything. Recursive is the key idea here. So you just use that option, and then you will have be able to use that on directories as well. So it's something you can try out. There are some mini tasks in the slides that you can try out later on your own, just to get comfortable with this. One of the key things that Windows users, if you're coming from that direction, often get wrong is that they Windows is a bit flexible or fuzzy, if you like, with the use of commands and parameters. For example, you can say something like cd ... right, in one line without space separation, and that will still work, meaning you're moving one directory up, right? Change directory, moving one directory up. In Linux, that won't work. You will get an error. Yeah, strictly separation. You always need to have a white space between the command and the arguments you're passing to it. Good. On that note, cd, yes, another worthwhile command, change directory, if you want to change the directory. Thoughts, questions, worries? So again, if you want to change directory, if you do this one here, cddd, that will not work. It will say command not found because it will interpret the entire 4 characters as a command. Please.
One question. Shortcuts.
Yeah.
Linking.
Getting there. Getting there. Yeah.
Is that something that one should consider relevant now?
Yeah, I will talk about this in a few seconds.
Okay.
So yes. So we touch. I want to go step by step. So Alice is getting literally now. Thank you. So that's right. So linking in Linux. So what is linking about?
Shorthand, making a shortcut to or multiple entry points to the same file.
Exactly. Yeah. So here that's the schematic example. If you want to, for example, have a shortcut from Jane's setup, and that's supposedly calling a generic file somewhere else, right? So you can redirect the calls conveniently. And yes, of course, you have that here as well. It's called symbolic or there's hard links and soft links, but we only talk about the soft links or so-called symbolic links. And the idea is basically there that you are pointing to a different file. And how it's used is quite straightforward. I'm going back to my home directory, so I'm not polluting anything else. And you have a file, my beautiful test file right now. I'm showing you right now ls-lisa. ls has a set of, before we get there, has a set of very helpful options that you can use. And most people, I think, use ls-la, and you can also substitute your ls alias with this one, so you have a default view. And what it does, it gives you simply more information, right? So the -l stands for, I believe, long list. Okay, right, as a list format, A for all.
Oh yes, I tend to capitalize the A to exclude the dot and dot.
Okay, right, yep. So you see that here the dot and dot, which we talked about as mechanisms of representations of the upper and same directory, can be suppressed using capital A. That's right. Yep. And so on. I is for showing the inodes, I believe, right? So showing you more information. We talk about inodes very briefly in a second. And S, I don't know, what is S standing for actually? Who saw it? Size? No.
Not sure.
I think that's the pointers, right, to blocks, number of blocks that it takes or something like this. Anywho, so it's definitely worthwhile playing around with your favorite, developing your favorite, ls-lisa notation, because it's quite relevant. Also, it's a good way of showing you all the hidden files. Hidden files in Unix start with the dot, right? So they will not be shown with a standard ls call. So you want to see all the hidden files that are lurking, for example, in your home directory. Quite a number of them in our case. You can see them this way. So, but now I promised to make actually a link, symbolic link, to, hang on, other way around. Classic mistake. So ln is the command, link, -s for soft or symbolic, then the file that you want to link to, in my case the test file, and then the actual name of the link that you want to see. And I'll show you now what's happening. So we have the original, I've used the mouse pointer so you see it on all screens. Hang on. Mouse is conveniently suppressed here. It's completely suppressed. Sorry for that. But you notice that at the bottom, second last file is the test file. And you now also have, that's the 7th last file entry, is called link and points to test. And this is now the symbolic link. So it's basically a shortcut that points to that very file at the bottom there. But they are distinctively different files, right? So the target file is different from the link. So if I delete the target file, the link will still persist, but of course not work. So, yeah, so I have a broken link here basically now. So ln-s. ln-s. Is it worthwhile exploring hard links or not? No way.
I was thinking about it, so.
Do you want hard links?
No, yeah, I want hard links.
You want hard links, okay. All right, okay. All right, let's do hard links and soft links. Who wants to explain the difference? So I don't need to.
I can't really remember. I just think that
Good.
a hard link is a copy. Is it actually a copy to it, or?
Please?
A hard link is actually when you create a hard link, you actually increase the reference counter to the actual file. So when you delete the file, you're actually decreasing the number of references in the operating system. So you have multiple inodes pointing to the same head of the file.
Okay.
Basically, at least.
So let's have a look. In fact, you'll find this will be quite obvious in a second. I recreated a test file right now. It's empty. That doesn't matter for that purpose. But on the front left, you see some numbers here, right? So they're really high and not seemingly systematic. They're so-called inodes. If you had databases before, you probably have databases now, right? Aren't you, right? You heard about the idea of the primary key, right? So unique identifier, and that's roughly what an inode is, right? So having the file name sounds kind of unique, but it's not the inode, E-node literally. And that was before Apple, so don't get it wrong. I think it's called information node. This is actually unique identifier. And if you use the hard link, so before I used the soft link, now I use the hard link, so I'm going to call it hard link. And I also create a soft link for sake of all right, let's see if we get that together. Boom, 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 boom. So you find that here's the test file. That was the original file I created. Test has the inodes 3074. Right? So then afterwards, then we created a soft link. So the soft link has the inode 3076. So it's different, right? So it's a different, distinctively different file, right, on the file system. Yet it's pointing to the test file, right? So it doesn't have any size in its own right, but it's just directly pointing to the test file. Whereas the hard link here, that's roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th file from the bottom, as you see, is actually, as you mentioned, pointing to the very same file on disk, right? So it's a second, basically a differently named reference to the very same uniquely identified file because it has the same inode, right?
If you delete the hard link, you also delete the original?
No, that's the point. You can even delete the original and you can still retain the reference to the file. So if I now say rm test,
the soft link will be broken though.
The software will be broken, but the hard link will not be broken. So where's the hard link? Here's the hard link. So it still will retain. It even keeps the same inode. It's, of course, the demo is a bit restrained right now because I actually didn't create any content there, so I can't really show you, but we could do cat hard link, or you can actually, but it doesn't show you much. And it shows you the content. And the file will only be deleted when the last hard link is deleted.
Okay.
Yeah? So, but the hard link is actually not recommended to be used. It only works within a given partition, so not across different partitions. For that reason that it points to the same location. So generally the recommended use is the soft link.
It's kind of safer to use soft links, and you can use them across partitions and so on.
So that's the kind of more, and that's the same way it's done in Windows as well. So it's conceptually the same. Please.
Will two hard links to the same file, will they share metadata like permissions?
I think yes.
I think so. I think so.
At least when I've used hard links for one thing only previously, and that's for synthetic full copies or backups. And changes to permissions in a file will persist through the entire synthetic backup. So I think so, yes.
Let's test it. So, yeah. Yep, it does. So, so we're just to summarize the discussion, what happened just now here. So previously we had a test file here and a hard link there. So they point to the same inode, right? The same unique identifier 3077. This is the permission system. We get into that in a second. permission system, and you see a permission is the same right now. Afterwards, I ran one command that changes the permission. What that means, I get to in a second. And you'll find that both the hard link as well as the actual target file change permissions. So yes, the permissions are carried over. So, but I forgot that myself. So yeah, so it's a really identical pointer to the same.
Do the same thing.
Same thing, fundamentally. Good. But let's stick with symbolic ones. Here's the syntax in detail, ln-s. Yeah, if you omit the s, you're creating a hard link. And this is thing I always get wrong, the target file first and then the link name. I always get the other way around. So see if you actually need it. Oh, damn. That's not fun. My battery's running low. So I'll do a unnoticed sprint to my office. Next one, I'll bring my ID card as well. So, what could we discuss in the meantime?
Yeah.
So.
Any questions?
Yeah,
While he's away. Yes.
Can you link directories?
Yeah.
Hard links them?
You can definitely link directories soft linking. I never done directories with the hard linking, so I don't know actually. But you can link two directories with soft links. Yeah, you can test it. Play with it. Yeah. Sorry?
Hard linking directories.
Doesn't work. Okay. Yeah, you were fast.
Yes, sprint, I mentioned it.
We only managed to deal with the question whether you can hard link directories, and empirically it's been shown that you can't.
Right, it's only files.
But you can soft link directories.
Yes,
Yeah.
that's right. It's another shortcoming. Right,
Yeah.
right. So hard links are just old-fashioned. So, okay, charging. That's good. Right, moving on. Okay, just some important files that are yet you will find on any operating system. Sorry, any Unix-based operating systems. So generally, I mentioned before, in Etsy you find host-specific configuration files. One of them is called passwd, which contains
Passwords. Or actually users, but previously it also contained the passwords
Yeah.
for the users.
So it's one of those path-dependent misnamers, I guess. It's called passwd, and it contained historically passwords. But they figured out, hang on, storing passwords in that file is like super obvious, and there were, the encryption was not really reliable. I think in the beginning was plain text anyway. So they removed the passwords from there, but it contains all the users registered on a given system. So if you're wondering which users you're actually running, and you have only a console at your avail, doing a cat on passwd is the way to go. And you see it's quite a large number of users. Yeah, it's quite a large number of users that you actually see here. Usually the ones in the beginning that you see are system users, daemon users so-called. In Windows you would call them background users, background system services, system accounts. Here it's daemons. And only in the bottom you see the ones that have been created by the user mostly. So here, for example, is the user account user. The second element is X. That is the placeholder for passwords. Okay. So placeholder for passwords, but it's no longer used. Then it's the so-called unique user ID. So users have a user ID. The group ID associated with this user. And apart from the other parameters, which I think is some descriptors and so on, so it's not entirely relevant. You find the user's home directory and its default shell. As Marius probably mentioned before, you can have multiple different shells on a different Linux system. In Windows, you have the command line, and that's exactly what you have, right? So there's not much space you can do. You can store your git bash command line, but that's just a different tool on top. But in Linux, you can natively install different command lines, and the ones that is run by default is indicated here for a given user. So doing log on, that's the one being used. Good. So leaving that aside, it's just a good way for you to figure out which users are in your system. And if you want to figure out groups, there's a file called, of course with directory here, Etsy group, that shows all the groups. Note the file is named in singular, group. A bit confusing at times, but here basically you see all the different groups and their group IDs. So everything has unique IDs in Linux, so processes, files, users, groups. Yeah, so that's the idea there. Good. Probably shouldn't go too deep. I mentioned already varlog syslog. That will only be relevant when you run your own services. So it may be actually relevant if you want to figure out if your system is listening on a particular, cat, of course. If your system is listening on a particular port, for example, if you want to figure that out, it's quite helpful for this purpose. Yeah, so, but I think I'll leave it at that for now. Those are the more relevant one. Is creating users relevant?
Yeah.
Yeah, briefly. So,
Briefly.
Super briefly. I don't want to be too boring here, so because it's not my most fun exercise either. So, in order to create users, you have, or in fact, to deal with users in general, you have commands that all start with user. And if you want to create a new user, I recommend you, if you do it interactively, meaning on your own, you just say add user and then your username, right? But there's also another command that's called user add, the one on top here shown in the slide set. And what's the difference between those two ones, if anyone knows? You need to use the right one in the right context. So they fundamentally do the same thing. They set up a user. The only difference is that if you want to do something non-interactively, meaning you want to, for example, script it in a bash script or automate it, you would want to use the top one because it basically creates the user in one command. You just say, create the user with the home directory /home username. Create the actual directory when you create the user. And this will be the default shell the user will be presented, and then the username. If you do this one, it will create the entire user, no questions asked. Right? So you just see a command line. This one is the interactive mode. It will ask you everything, including office number, first name, last name, and toothbrush color. I don't know. It asks you a lot more than you probably want to enter realistically. Right? But it's worthwhile if you want to script, don't use the second one, because then you need to deal with interactivity on a console, which is convenient if you controlling the system yourself, but not, again, if you want to automate or script. Cool. Yeah, so much about this. So I just leave, anyway, the slide set is at your avail. You can play around with this and explore it on your own. It's not really worthwhile going too deep into this one. What is important, however, is to think about dealing with super user rights. And I think, did you talk about this briefly? Oh, yes.
No, we mentioned that there is a super user.
There's a super user.
But we haven't dived into it.
Yeah, so we will, probably are not going to deep either, but the idea is there that in Linux, unlike often in Windows, you're not working with elevated rights, right? So there's always one user, which is the root user, which has the rights to obtain all privileges. It doesn't mean that it has all privileges, but it has the right to obtain all of them. And by default, any user you create will not be a super user, but it will be a regular user. But the user may be in the position to actually run super user commands. And so you can kind of control this ability. Groups. Yeah, so. And the default way of doing that is to make this user, when you create it, after you create it, make it a member of the group sudo, at least in Ubuntu and in Debian-based systems. This way, the user will be able to call the command sudo and then do something, sudo ls, for example. But notice here, if you can see that. So I wrote sudo ls for anyone who can't really spot it. And it will ask you for a password for that particular user. In this case, it's just a confirmation that you actually want to enter this privileged mode and run this command with super user rights, so the most powerful user on the system. It doesn't do anything different, but if for commands for which you won't have the privileges, for example, configuring your network card, you will need to run the super user command, otherwise you won't get really far. Yeah? And it asks you for your own password, not the super user password, and then you can actually get the output, and I probably got it wrong again, so yeah, whatever. I'm not good at typing simple passwords. So, right, there you go. So if you want to, however, the notice here that sudo actually doesn't change much. So it runs this command in super user permissions, super user do, but then returns you back to your old privilege setting. So it's really only for that command. So very clever from a security perspective. However, if you want to make that more permanent, so meaning you want to actually act as a super user, you can run the command, which I prefer not to have told you, sudo su. So it's basically enter the super user mode, switch to super user mode, and you see what's happening here. Your entire prompt changes. Now it reads root at Ubuntu, again user at host, and then the directory you're currently in. Note that the root has its own home directory, so it will now show the user's directory explicitly because it's not the root's own directory anymore. And then you see hash instead of $sign. Every time you see this hash in the prompt instead of $sign, it means you're working with super user privileges, meaning you can break everything, right? So you can, control your system to its entirety. Right. So, please pick up. Oh, very much so. Thank you. You're welcome. So now we are working as super user. Now, how do you get back? Assuming you want to get back to normal user.
Just write exit.
Right, exit, right?
Control D.
Oh,
to
yeah.
log out.
That's right. So, and the idea is here, or the understanding here is to see that those shells are nested, right? So you're entering as a normal user, you're elevating your privileges to a super user, you're exiting from a super user, becoming back to normal user, and then you can log out, for example, and be logged off from the system or whatever else. So it's like you can always exit again from this mode using exit if in doubt. Yeah? Please don't just work as super user now. That's the disclaimer that needs to follow of this statement, because I know the first people, cool, I found it. That's the magic command. Solves everything, sudo su, don't. And you'll be surprised how little you actually need it. You get away with quite a lot without doing it, unless you want to change system characteristics, particularly hardware or fundamental system settings. Basically anything in Etsy is somewhat super user dependent. Good. Groups, I'll jump groups for now. So users will have groups, and users can be members of one or more groups. They can have a primary group, and they can have secondary groups. So what's the difference? Well, if a user each user has a primary group, and the idea is we need to be able to tag files and directories that we're creating with the user that created it. So therefore, we also need to say which group created a particular file. And that's what primary groups is really about, to say which authorship group a user has. You see that in a second when you see the permission system. Secondary groups is any further groups and users associated with. I mentioned just now, for example, the sudo group. You can add any user to the sudo group, meaning they can now do something as super user. Or the modem config group, or the CD-ROM group, which means they can eject and mount CD-ROM drives. Or so there's a lot of those groups there of secondary relevance. So I'm not going into that one. I leave you with the slides. You probably never need to play around with this, but it's more important to understand what it actually does. Good. So we're running out of, we can still do that. So, okay. The other thing is that you probably moving away from users for a bit, more or less permanently, is the environmental variables. So when you were setting up the Go environment, you most likely needed to modify your path variable. Yeah, right. So if someone didn't have that, didn't come across that, most likely your Go installation will not work. You will need to do that. And
then it might not be as obvious as changing the path variable for the export in the bash RC file.
okay.
That's what we did, so it might not be obvious that we were actually changing our environment.
I see. Okay. Okay. Yeah, fair enough. But well, in principle, you did anyway, right? So what's the path variable about? Anyone?
It contains locations for several programs, for example. You can have a path variable to Java. So when you type the Java command, it checks the path. So path, is it like a folder, or is it just a variable and tries to see if the location is there? So it is a variable that contains like this absolute paths, I think, to commands.
It's generally folders. But
Sort of, yeah. It's a variable containing all location of all binary or executables that are accessible from the normal terminal.
Okay. Yeah.
So what does that mean? Let's try and translate it back to the normal user. What's the benefit? Why do we do that? Why don't we just, enter the...
It's so the operating system, Linux in this case, will know where to start looking when you type a command. What do you actually want to do?
Yeah. So...
You don't have to type like a long path.
Without having to use the absolute path or relative from where you're standing. Yeah.
Exactly. So we talked earlier about this absolute and relative path business, right? So, but also I talked about the fact that there's actually files contained that they are. Hang on, I need this one here. That they are different directories, such as the bin directory and the sbin directory. They all contain executables that you use, like for example, the ls command and so on. Those are all executables that are part of the Unix core util collection, and they are located somewhere, and they're not sitting on the main directory. So the system needs to know, okay, where do I actually look from a perspective of a particular user? Where do I actually look to find those commands, right? You could tell the system, well, go through all directories and all files. So after half an hour, you probably get some feedback, but don't type that command again because it will take same amount of time. Instead, you actually tell the system, hey, use those folders with preference. Right, so you indicate kind of a lookup path, chain of lookup path that the system should iterate through if it's looking, for example, for ls, for any of the commands you're actually using. Right, so and that's what the path variable is about. Anything that you add to the path variable will be available from any location in the system. So the reason is that you guys are able to type just go or go build or go format, go test and so on from any space. Is due to the fact that it's part of the path variable. Otherwise, you would need to go to the location where Go is actually installed, which is, tedious to find and may actually vary in different systems, maybe version dependent and so on. And using this path variable, you can make it uniform and just have ensure that Go is available from any such location. And the system has a number of those variables, and it's not only the path variable that you have seen, but actually a far wider set of those ones here. If you type env, standing for environment, that lists all the possible, all registered environment variables that your system has. And there, for example, includes something like shell. If you want to figure out what your own shell is, you can just type echo $shell. There you go, and it resolves the variable, which is bin bash. So this way you can look up a lot of user-specific aspects that are encoded here. Or $user is your actual username, if you need to know that. For example, you're writing a script and you want to ensure that this user that is running that script, uses its username for whatever reason. You can just access it by saying $user. So it's kind of a variable approach to that one. Or if you want to change the language and so on of the system. So you find a large number of those. So one comment again on the path variable. So just say echo path. The order. So you see that it consists, the path variable, if you run it in your own system, you'll find that it's one directory, home user bin, colon, so two dot thing, right? Colon, slash home user dot local slash bin, colon, and so on. So the colon is the separator, the delimiter between the different locations that you're specifying. And the system traverses through those different locations in that very order you specified, right? So from a performance point of view, it's quite relevant to think about it, but also from a priority point of view. Imagine you have two Go installations in your system, right? One for a stable environment, right, 1.10, and one for a dev environment, 1.11. Then you can systematically, substitute the path or the Go installation you want to use for a particular context, right? So you're only using Go for 1.11 for a particular purpose, or 1.10 for another, just by changing the path variable, as opposed to changing the actual installation and the like. Yeah. So that's the key thing. It goes in the order of specification here. Anything to add that's worthwhile? No. Good. Good. Okay. So I encourage you just play around with this. You look at the variables. env is your command if you're interested. If you want to have your own variables you want to add, you can do that in the file .bashrc. And if you don't see that file, it's because it's a hidden file. So you it means you need to use you know, ls-la to actually see all the files in your directory. Otherwise, it will be obscured from you. And the reason is mostly that every user has that file, but not every user is a system, you know, that don't work on a system that just want to write their text documents, and you want to avoid them deleting their own environmental configuration. That's why it's done that way. Note, if you specify a variable, which you can do at runtime, it's specified, and that got tripped up over that in the beginning quite a bit, without a dollar symbol. So you just say the variable name and equate it with, you know, the value you want to associate it with, but you don't use the dollar symbol. But when you reference it, when you actually use it, for example here, echo, you know, dollar var, then you will need to use the dollar sign. So yeah, that's one of the things to bear in mind. Yep. Good. So here's the path variable, some ideas of how to extend it, so you can manually modify it on your own. Okay, permissions, that's the big one. Do we have the time for permissions?
6 minutes.
6 minutes. 6 permissions in 6 minutes. Okay, there's 2 approaches to permissions in Linux. Let's see how far we get. And one is to have a representation by octal values and alpha symbols, and since that sounds scary, let's just get on with it. So if we talk about permissions in Linux, we need to come back to the file concept that we saw earlier, and the structure that we probably saw earlier on the command line as well. And the idea is that permissions are generally organized by different, each entity, meaning a file or directory, has permissions. And the idea is there that is organized by different user types, one being the actual owner. So what permissions does an owner, the user, you, have on a particular file? What permissions does an owning group have on that file? So the idea is there, if you have a group with multiple members, what is their permissions on that file? And which permissions does anyone else have? Right? Anyone else. So that's the key idea. And that's how it's organized. So we have those 3 types of users. And then there's, of course, the permission specification. And the only permissions that we know here is read, write, and execute. So read, write, and execute. And this is specified then per user type. So for the owning user, for you, RWX, then we have the same for the group and the same for everyone else. That's the kind of symbolic representation that you'll see in the command line. I'll bring that up. So if you type ls lisa again, so one of the extended LA will do as well, you'll see it here. In fact, you see a 10-character specification of the permission set. So, for example, let's use this folder archive here. So the very first character here is actually not directly related to permission. It just indicates what type of object you're dealing with. In this case, for archive, it says D. And this is kind of the meta information here, and D stands for directory. That's your way of figuring out, oh, I'm actually dealing with a directory, not with a file. If it's just a slash, a normal slash, then it means it's a regular file, right? So if it's a link, you have an L there, for example, down here, the 5th from the bottom. If it's a B, it's a block device, C, character device. So we were earlier in the device folder. There were a lot of those character devices and block device. Anyway, so the first one you can largely ignore. The only thing that's relevant for you is there a D, or is it just a slash, a minus, basically, right? So, and that indicates a regular file. After that one, you'll see something like RWX, and here's R-X. And what that basically means is that for this particular folder, the owning user has all privileges, so it can read, write, and execute. The owning group can do the very same. And for everyone else, everyone but the owner and any non-member of the group can only read that directory, and they can execute, which in directory lingo means enter the directory, right? But they can't change it. They can't write to it. Yeah? So that's the key idea here. And how do we now figure out who is the actual owner and who is the actual owning group, if you like? And those are the ones over here. So user is the owner. So the user owns the directory. But there's also a group called user. And this group is the owning group of the directory. And here, this is a bit of a, it comes back to the primary and secondary group idea, because by default, this owner and owning group field needs to be filled in Linux. You can't have them empty for any file. So by default, if you create a user, the system also creates a private group for that user. So in worst case, if you don't want anyone but yourself to access a file, only you can do it because you're the only member of that group, because the group is named after you. Yeah, so that's the whole business about it. Please.
Yeah. Can someone see that the file exists if they can't read it?
Can someone see if the file exists if they can't?
Unless they know that
Yeah.
in their files that they don't have the permission to
Yes,
read
they
it.
can see, yes.
Okay.
So if they can access the directory, that would be the accessing directory permission. If they can access the directory the file is contained in, they can see the file name and the meta information. They will also see the permissions. They will also see who the owner is and also see who the owning group is. But like you say, they will not be able to see the contents of that file. Yeah? Good question. So the difference between file and directory is a bit confusing. We get to that in a second. So, however, life was not meant to be easy because there was Unix people involved in developing Unix. So, and they thought, okay, let's make a very clever generic permission system which works in, I think, 90% of all cases, not always. Delegation of groups is there. There are some shortcomings there, but the idea is basically that you have a bit representation of the permission system. So, either you have a particular permission, RWX, or you don't. That boils down to the binary representation to encode the individual positions of permissions for the individual users. And then if you have a decimal representation, you can sum up the resulting permission set. So, for execute permission is binary representation in the value 2 to the power of 0. For writing is 2 to the power of 1, and 2 to the power of 2 for reading. And if you convert this then again to 4 and 2 and 1 in the decimal representation, you sum it up, you can infer the permission set on a particular file for a particular user. So if I'm doing something like, hang on, I still need to optimize my switching, yeah? chmod, which is the command for changing permissions, and I have my test file down there, and I just want to give myself, how do I do it? If I want to just give, let's be safe, and give the owning user full permissions so I can actually do something with the file afterwards, but let's say we want to give the owning group only write permissions, what do we do? Which octal would we need to enter there? 2, right? So, cool. Right, so, and then we need to have the file, and if we say ls afterwards, note before that, read, write, and execute permissions were granted for the user and the owning group. Afterwards, we have read, write, and execute, but only write permissions for the owning group. So what the decision here was basically is just to flick this bit here, which boils down to a decimal 2, meaning we just represent it as 7200, 0 meaning because anyone else should not have any sort of access to a particular file. And this simple, relatively simple system, you can have a fairly complex permission system that you can devise for files and for directories. Yeah? So this is how basically the setting permission is linked up with the representation here, if that makes somewhat sense. Does it make sense, by the way? Because I did it in 6 minus 1 minutes, meaning I actually in 7 minutes, because I'm over 1 minute over already. Does it make sense somewhat? If not, yes, so that's basically the idea there. In addition, so we just go through those ones. So what would 0 means no permissions? What would 1 mean?
Execute.
Execute permission, cool. Someone else with 2?
Right.
We fix that out, cool. 3. Yep, cool. Right, and execute, right? So for
Read.
Cool. Yeah. So I think we got the gist here, right? Good. So read and execute for 5, and then read write for 6. And if for all permissions, then it's simply execute. So that's basically what it's all about. And that again is generic, holds for any Unix system, right? So if you bear that in mind, you get actually quite far. In addition to this octal representation, there's also something like this. So chmod is the modification of the permissions. Is the command for that purpose. You can, instead of specifying using the octal representation like 740, for example, for file name permission, you can also use u equals, and then the permission you're interested in. For example, if you want to give the owning user, for example, only read permission, you would say u equals r, and then comma group equals, I don't know, rwx, and so on. So you can be quite explicit about the permission set if you don't want to dive into this octal representation. there. So that's alternative way, which is a bit more legible. Some people prefer that. So this means you're actually specifying explicitly the new permission set for a file name. This means you're changing the permission set. So for whatever the current permission on the file name is, remove the execute permission, add the write permission, and for all others, they're only allowed to read. So overwrite the permission set and just set it to read only. So, yep. Yep.
Was a question.
Oh, sorry, which one? Next time throw a rock if I didn't hear you.
Yeah, that was a question.
Are you alluding to the fact that we're running overtime?
Huh?
Are you?
No, it's not important.
Okay, cool. I just wanted to get it across. Good. Yep. Anyway, yeah, I think we leave it at this. Otherwise, we run into trouble.
Yeah.
And we, continue somewhat there and wrap that up. So before we move into REST and other more meaningful things. But I hope you get some baseline understanding of what's happening in Linux here.